Hello. Here we go again. 7.2. 7.2 is going to be broken up into 2 days. So we're going to do the first page front and back the first day, and the second page front and back the second day. And then this whole big assignment, which is not too big, will be due on Monday when I get back. So, by the way, I was wrong in my last video when I said I was on a plane flight. I forgot the fact that you'd be watching that video on Tuesday, not Monday. I left on Monday, so I guess Wednesday, I think I will be at Animal Kingdom Wednesday in Disney World, watching like giraffes and stuff from the safety of a vehicle in a carefully controlled environment in Florida, which should be fun with my kids. I'm sure I'm missing you guys at this point, whether or not you believe that it's actually true. But let's get going. So there are 2 ways to do a hypothesis test. One is doing something called p-values, like probability values, which are not, we're going to handle the second day. And then day 1, we're going to do something called rejection regions, which is how I prefer to do it, but you do have to know both for the AP test. So what we're going to do today is we're going to keep on kind of flipping back and forth. We're going to do the directions, and remember one of these good old charts that have 2 sides that you like, and then we're going to do example 1 together, and then you're going to do example 2 on your own. So here we go. The first step of hypothesis testing for a mean with rejection regions is to verify that sigma is known and the population is normal, or n is greater than or equal to 30. I think you remember from the central limit theorem that if n is greater than or equal to 30, if we're taking samples that are n is greater than or equal to 30, we can basically say that it will be normal. That is in the problem. So it'll say directly whether it is or not. So flip your paper over. We're going to look at example 1. Remember, if you need to pause or whatever, then do so. I'm going to go pretty fast. So let's see. Example 1. Employees at a construction and mining company claim that the mean salary of the company's mechanical engineers is less than one of its competitors. So they're claiming that they're getting paid less than their competitors, which is $68,000. A random sample of 20 of the company's mechanical engineers has a mean salary of $66,900. So they basically took a sample of 20 of the engineers and they found that it was this. Now you may think, okay, great, they proved it. They're less than $68,000. But they could have gotten a weird sample. They could have just happened to pick people that were lower than that $68,000. So since they're saying that it wouldn't be equal to $68,000, that it's less than, we have to see if it's less than enough to be like officially true. We're assuming that the population standard deviation is 5,500, which is what we're looking for in this step. So it says population standard deviation. This is just like confidence interval tests. It says population standard deviation. We know that the sigma is 5,500, and it says that it's normal. So I'm going to write normal, check. If it wasn't normal, then you would have had to test and see if the sample was greater than 30, which it's not in this one. And if it wasn't this, you couldn't do a z-test. You'd have to do a t-test, which is the next section. Step 2 is we have to state the null and alternative hypothesis. And the claim. And remember that the claim can be either of them. It can be the null or the alternative. All right, back to the example. So I'm doing an H sub O and an H sub A. It says that the mean, they have a mean, they're saying that they're claiming that the mean salary is less than $6,800 or $68,000. So if it's less than, not less than or equal to, that must be an alternative. That's less than $68,000. That is the claim. Opposite of that is that the mean is greater than or equal to $68,000. Okay. Step 3. Step 3 is to determine or specify the level of significance and decide if it, what kind of test it is. The level of significance is denoted by alpha in the problem. It looks like an A kind of. So alpha is the level of significance, or like kind of like one of those like Jesus fishes that are on cars. By the way, level of significance, this is also the probability of a type 1 error. So we're basically saying, like in this problem right here, since alpha is 0.05, we're saying we're willing to be wrong, have an error possibility of 5%. So we're 95% confident, this does relate to confidence intervals, 95% confident and 5% thinking we might make an error. All right, and we decide what kind of test it is. The test could be left, it could be a right-tailed test, or it could be a two-tailed test. All right, on this one, it says here in the problem that the alpha is 5%. That means that we are 5% likely to make an error, 95% confident about what we're saying. Also, remember that the alternative follows the tail. So alternative tail, it is a left-tailed test that we're going to do. This should be stuff that you know from 7.1. All right, step 4. Step 4 is to determine the critical values and the rejection region. The formula that we use for this is z equals x bar minus mu over sigma divided by the square root of n. That should look kind of familiar with the x minus mu over sigma, and this down here is called the standard error, which is used in the central limit theorem, sigma divided by the square root of n. Okay. Oops, no. Oh, I made a mistake here, I'm sorry. This formula actually goes down here. That's for our standardized test statistic. My apologies. This information for rejection region is on A16 and A17, and it really helps to draw a picture. Sorry, I am not going to re-record because that would take too much time, and there's no reason to. So for number 4, I'm going to draw a picture of a left-tailed test. Here's my tail. This is my rejection region over here. And here's my null over here. And then I need to figure out what my line is. Basically, where would I reject and where would I accept? What z-score would I accept or reject on? For that, I know that my alpha is 0.05. That means that there's 0.05%, or sorry, 5% in this tail. So I'm going to grab my z-chart, which is on A16 and A17. It's that chart, that z-chart, that one of them is negative and one of them is positive that we learned how to use in the confidence intervals. And you're going to be looking up 0.05 on the left. So 0.05 in the middle of the table is right here. Again, if I'm going too fast for you, then just pause. That is a z-score of negative 1.645 because it's halfway between these two. So our kind of rejection region here is negative 1.645. So if we